With that, I'm going to turn it over from my MC self to my presenter self. So I'll be giving today's presentation, Learning to Use AI for Scientific Computing Productivity, Part 1. This is going to be a 2-part summer school. I'm going to give you some goals of these summer school sessions real quick. I want you to understand what generative AI is and how it relates to other areas of AI. That will be brief, but good background. Understand what large language models are and how and why they work. That's actually important even if you use them already. It's important to understand how and why they work because that helps you understand what their limitations are as well as how to overcome those limitations most of the time and use them most effectively. We're going to talk about how to use tools based on LLMs. If you're already an expert in this, today's session may not have a lot of new material for you, but I do think it will reinforce what you already know. And I hope that I have some ways to share this content that will still be useful even for the experts in the audience. What we will not cover is all of the math and science of deep neural networks. You might see a few equations in a few slides because it's important for context, but we will not get into the math of deep neural networks. And we will not get into today how to develop AI agents and applications. So I'll show you how to use AI to develop regular applications, scientific applications. So the topics in the agenda today, we're going to cover what is AI, what are Gen AI chatbots and other tools that use LLMs, and what is agentic AI. In 2 weeks, on August 26th, we're going to do mostly demos and labs using some of our tools, including our Gemini command line interface and Gemini Code Assist. We'll get into those today by the end of the session. So don't worry, we have a few demos and labs for today, but we'll get into more of that in part 2 of this. So first, I want to get to know you. If you've used a chatbot before, hit the plus sign in the meet emojis. I assume everybody will do that. We'll probably see an exploding number of plus signs. There we go. How many of you have used AI tools, daily or at least weekly? Do a thumbs up if you do that. Thumbs up if you use AI tools daily or weekly. Great. How many of you have programming experience? Give me a sparkly heart if you have programming experience. Awesome. Confetti if you have scientific, or the horn, the celebratory horn, whatever that is, if you have scientific computing experience. Great. And if you have computational research experience, give me a plus sign. Computational science research, good experienced crowd. How many of you have experience developing AI applications? Let's go back to the sparkly heart for experience developing AI applications. Good. Research experience in AI. Let's do the celebratory horn there again, the confetti horn. You've got research, awesome. And how many of you have vibe coded? Let's use the crying smiley face because that term is so funny. All right. Good. So we got some experienced folks on the line. Let's jump in. So first is going to be a bit of theory and context, and I'm going to go through this quickly. This is from a longer tutorial that I gave a couple of weeks ago, but this is a smart crowd we saw from those meet emojis and experienced crowd, so I should be able to move through it quickly. You've all heard quotes like on this slide. AI is the next great thing. It's the best thing since sliced bread, or more commonly, electricity. It's the next great transformation. It's disruptive, and so on. I really like the quote by Faith A. Lee, one of the thought leaders in modern AI, where she says artificial intelligence is not a substitute for human intelligence. It is a tool to amplify human creativity and ingenuity. And in that spirit, we'll be teaching you in these summer school sessions how to use AI to amplify your own creativity and productivity. It will not be a replacement for you as a scientific or technical computing professional, but it will enable you to amplify your productivity and ideation and inspiration, and make you more effective. You've probably all seen this diagram before. AI is a broad field. Machine learning is the current dominant class of AI in use. It used to be expert systems with the dominant form. Now machine learning is the dominant form. And there are subfields within machine learning, including deep learning, and now generative AI as a subset of deep learning. Quick question, is linear regression machine learning? Thumbs up if you think yes, thumbs down if you think no. Savvy crowd, not fooling anyone here. We learned it in our first statistics classes, all of us long ago, but it really is a form of machine learning because you're taking known input and output data, developing a model, in this case, a straight line, and using that model to predict new outputs given new inputs. And you use the slope, the formula for the slope and y-intercept of a line, and recognizing that all the initial data points did not fall on that line, you're trying to minimize the sum of the square of the errors for those points so that you can get the best possible fitting line and make the most probabilistically accurate assessments of new y values given new x values. So linear regression is the hello world of machine learning, but it continues to play a part even in more advanced deep learning techniques, as I'll show you in just a second. So there's a lot of machine learning and widespread usage. The generative AI we're going to talk about today does not depend on these methods explicitly, but it comes from this lineage. And specifically, it comes from a branch of machine learning called deep learning that uses artificial neural networks that were inspired by biological networks, but don't operate exactly the same way. You still have inputs, and the left side of this slide is the input layer slide. And you may have images with cats, dogs, and sandwiches. You may have 3 different kinds of inputs on the left. And you might be asking the question, is there a sandwich in the picture? And so your output layer may really just be a binary answer, yes or no, because you're not interested in cats or dogs. Or maybe you're trying to classify all of the above, and then you'd have multiple output types on the right. And you've got these intermediate layers that are doing sophisticated computations beyond what we're going to get into in this presentation, but they're trying to find features in the images or the other unstructured data, text or audio or whatever it is. They're trying to find features and developing models, including a classifier, so that you can begin to train a model to understand new inputs. Now, this is all based on the artificial neuron. Every one of those circles was an artificial neuron. And guess what? Linear regression still plays a role here because it's helping do the math to calculate the weights to end up training a model that will be more accurate when you give it new unstructured inputs and it has to make output decisions. So very simply put, machine learning is used to train a model with known inputs and outputs so that you can infer values when you get new inputs and don't have the corresponding answer yet. It helps you get these answers. It helps you make inferences. They might be classifications or predictions or judgments. Machine learning and deep learning are not new, but they're more powerful in recent years due to the advent of very powerful computers, the availability of lots of digital data, in particular unstructured data, which deep learning is so powerful for. So that's a quick bit of background. Now, you probably all know, since many of you are experts, that even deep learning, doing all of that complicated math, is not perfect. And it can still be confused by simple challenges that hopefully all of you as humans can make out on the left side, which ones are cockapoos and which ones are pieces of fried chicken. And on the right, which ones are blueberry muffins and which ones are chihuahua faces. Actually, a couple of those took a second for me on the right side. But I think that you'll all probably go 100% on those. But this is a tricky problem for AIs using our current methodologies because they're really not familiar with the concept of a piece of chicken or a cockapoo or a blueberry muffin or a chihuahua. They're finding patterns using those deep neural networks in the images. And the patterns, as you can see, are pretty similar between the 2 object types on the left and also between the 2 object types on the right. Now, you're probably aware of the fact that ChatGPT was the famous thing that launched the era that we're going to dive into today in today's summer school. You might have forgotten that it's less than 3 years old. It seems like it's been around forever already, and it is less than 3 years old. It actually, it's a bit more than that. It started in 2017 with a paper published by people from Google called Attention is All You Need. And they figured out a way to use deep neural networks in what's called a transformer neural network. And this is a diagram of the transformer neural network. It becomes very powerful at ingesting unstructured data and using unsupervised learning techniques to try to make sense of that data and organize all of the patterns found in that data. And with enough compute power, you can train a model on all of the text in the internet, for example, and find the recurring patterns through the word order in all of those sources. Today, trillions of dollars of valuation are based on generative AI alone. That's a remarkable amount of valuation for something that's only become mainstream less than 3 years ago. And real simply, these transformers protect for text prediction, for example. We're going to focus on text today as opposed to audio and video, but I'll mention that. But we're going to focus mostly on text. Are trained on vast amounts of text, and you get this pre-trained transformer model. That's what the PT in ChatGPT stands for. And it can produce sequences of tokens, which are composited together, become words and sentences and paragraphs and lots of text. And as they continue producing more and more tokens, resulting in words and sentences and texts and paragraphs, they have more and more context and can produce more and more. But it's based on that tremendously large model and something called a prompt that we'll get into. Now, you've probably heard a few terms about these models, like foundational model. That's a large general purpose generative AI model that serves as a reusable base for many different and more specialized applications. In today's summer school, you're going to hear about some of the specialized applications that Google offers that are built on its foundational model, Gemini. You may have heard the phrase frontier model. A frontier model is a foundational model, but it represents the very latest capabilities, the state-of-the-art capabilities that the model training company or organization has embedded into it. A large language model is a type of foundational or frontier model that specializes in text. And Gemini 2.5 Pro is all of the above. It's an LLM foundational model, and Gemini 2.5 Pro is really a frontier model. It has lots of great capabilities built into it, including a massive context window, up to 2 million tokens in that window. So those little blocks in the diagram from 2 slides ago, it can remember 2 million of those, and that feeds its ability to know what to predict next. So the larger that context window, as well as the larger the overall model, in general, the better it is at knowing what to generate next. So some important points about generative AI LLMs that will be useful to you as you think about these from a scientific computing context. Think of the model as an organized source of all information. That's powerful in and of itself. You're used to using things like Google search to find information that's out there on the web somewhere. In an LLM, all of that information has been used to train a model that can now act as a brain of all of that information and repeat that information back to you with a conversational interface. And that's the second big important point. It's language-based. That is the organization scheme, because it was unsupervised learning on language data, so language becomes the interface to using all of this information. Thus, you can learn almost anything. If it's been published out there, it's been trained into these models, so they're wonderful tools for learning. You can generate almost anything within the scope of the training data, and you can analyze, synthesize, and transform one kind of corpus of text into another, for example. Always remember, it's math, not magic. This is an experienced audience. You know this underneath. It's doing additions and multiplications. It's solving some equations. But it seems very conversational, which is why it's taken off. It seems almost like magic to people, but it's just doing lots and lots and lots of math beneath the scenes. The better you understand all this, and the more work you put into using generative AI, the better your outcomes are going to be. So don't treat it as a magic box that you can ask very simple questions of. Treat it as a tool, and the better you use that tool, the better your outcomes will be. So how do you use it? You use it with prompts. So once an LLM is trained using massive data and deep learning methods, these transformer neural networks in most cases, it can be used to generate patterns of words. You start the pattern with a prompt, and that tickles the part of the trained model that begins responding by generating tokens and text that is in accordance with the prompt that you use to kick off the process. So the prompts can be short or long and detailed, but the better the prompt, the better the odds of generating something useful. And then along with that, you can iterate on that. And the more you iterate, the more likely it's going to be even more useful. So they have these context windows, and that allows iterating on these results without having to keep starting over. If you don't like the results of your prompt, you don't have to start over. You can just continue improving it because it knows what it's produced in the context window, and thus it knows how to respond to your commands to improve upon that. So prompting is incredibly important. in everyday use of these chat tools, but in particular in scientific computing, as we're going to show in some examples coming up. So you can ask it to do something easy, but without much guidance, it's going to probably miss the mark sometimes. What you really want to do is make sure you're clearly stating the goal in clear language. It was trained on language, so that's essentially the programming language of these chatbots. Use clear language, say what format or context this is for, what topics you want it to include, and also exclude. People forget that you can tell it what not to include as well. Provide any requirements that you want included in the answer, and you can even give it notes on style and tone because it's been trained on the world's text, and much of that text describes tone, such as dry or funny or sarcastic. So they're even good at replicating human tone. You can and should iterate within these sessions, as I've mentioned as well. Now, this is a picture of the basic prompt cycle. And so most people are aware of prompts, but they sometimes forget how important that context window is. And this is from a great website called promptengineering.org that I hope that you'll tune into. So the user in the dark blue box executes a prompt. That prompt is in the context window. It's the beginning of that context window. Actually, it's the beginning of a new context window. You can save your context windows with different names, and those context windows have memory. So I have multiple context windows saved to perform different roles in my life as different kinds of advisors for different things I do. And each of those context windows has different texts and prompts in it and is better at generating the next thing I need according to that context. So it goes into the context window, it's fed into the LLM, you get some output. That output appears in the context window, and you can continue prompting into the context window. You'll keep going into the LLM and producing more output. And the more you guide it, the better it gets, because everything in the context window is used to guide everything it pulls out of the large trained model. So you might be asking, well, then why don't they pull the same output every time? When I write my scientific application, 2 + 2 always equals 4. So why are these things, if I give it the same prompt twice in a row, not producing the same thing? This is important, especially in scientific and technical computing, to understand. So I've got a couple of slides explaining this. So temperature is the parameter that controls the randomness of the tokens it generates. Now, this is an important point. If you ask it a question, it will almost always give you the same semantically meaningful answer, but it might phrase it in slightly different ways. And that's because of this temperature variable that introduces some randomness just so it seems more human. And it's a little bit creative in this. But a low temperature gives you precision and some predictability. So the model becomes not deterministic, but more deterministic. It will almost always choose the statistically likely next word. So if I said peanut butter and, it would almost always choose jelly and rarely choose banana for that. The same prompt will give you nearly the same answer every time. This is good for data extraction. This is good for code generation. This is good for factual summarization. These are things that are important in scientific and technical professions. You want more determinism. You're probably less concerned with, in these kinds of tasks, with creativity. You're more concerned with accuracy. But you can also turn up the temperature and make it higher. The higher you turn up the temperature, the more randomness is introduced, and that gives you some creativity and exploration. What is this useful for? If you're generating prose or stories or different kinds of communications, you might want to turn up the temperature a bit instead of just settling for the default. And you can do that with tools like Google's AI Studio. But generally, people, when they use chatbots, I've noticed they tend to just use the default, not even learn how to change the temperature, and then iterate on the prompts to get the kinds of things they want by saying, okay, be a little more creative if they want that. So that's another way to go, but you can tune the temperature, and that changes the default kinds of token generation it does. This is good for things like hypothesis generation. You'll see an example of that coming up later in this session. Drafting prose, you'll see an example of that, and creating analogies. So that temperature variable doesn't change unless you change it. It's generally chosen at a pretty conservative value, but even at a conservative value, the answers won't be phrased identically, even if they're very commonly the same semantic answer. Now, of course, the more you turn it up, the more likely you are to get a hallucination. And that's one of the reasons that the default temperature is pretty low in most chatbots. You may have seen this example before, and if you can't read it on the screen, the prompt was, what is the world record for crossing the English Channel entirely on foot? And not so long ago, chatbots would make up very confident sounding answers that were completely wrong about made up people crossing the English Channel on foot. There's a lot more fact checking and source checking in chatbots these days to prevent this kind of thing. But you should be aware that it doesn't prevent it 100%. They can still hallucinate and they can still give you realistic sounding answers with confidence that are false. In fact, there was an example floating around the internet a few months ago in 2025, where you could ask chatbots, where does the phrase, and then you make up a phrase that sounds like a colloquialism or a famous idiom or something. Where does it come from? And most chatbots were looking at the tokens in the phrase, not the exactness of the phrase, and making up plausible answers where it came from, instead of simply executing a Google search and saying, I don't see this phrase being said anywhere before. Again, that has been addressed in all major chatbots as well. So effective prompts include having a persona, a task, a context, and a format. And that's important no matter what kind of output you want, but it's going to be particularly important if you're looking for technical information, right? If you say, I have a cold, what should I do? It's going to give you one answer. If you say, I feel very sick, I think I have a cold, you're the world's leading expert on rhinoviruses, what do you recommend I do? That second prompt will generate an entirely different answer. It may have some of the semantic overlap, but it will now talk to you as an expert as opposed to as your best friend. This is just an example here of putting all four of these components in and the kind of email it generated on the way out. Now I want everybody to open in another window a chatbot. I'd prefer if it was gemini.google.com, but you can load any chatbot you want. Load that chatbot and just say, write a script for my data, right? You're probably going to have trouble getting anything useful out of prompt 1 on this slide. Write a script for my data. But if you open a new context window and enter this prompt, act as an expert scientific programmer using Python. I have a CSV file named reaction_data.csv with the following columns: time_seconds, temperature_Celsius, pressure_kPa. My goal is to find the maximum temperature recorded and the exact time at which it occurred. But please write a clean, well-commented Python script that does the following, and you can see the steps on here. If you execute something like this in a chatbot, it will absolutely generate code that does this. There could be a bug in it, but this script is so easy and they've been trained on so much code, I think it's better than a 99% chance it'll write the code to do exactly this that will compile. Now, will it run correctly? Well, not unless you have a file called reaction_data.csv, but that's not the assumption is that you have that file with that. And then it would actually run that if you have that file and it has data in the format that you specified for the code. This is really powerful, right? This is much quicker than writing the Python code to do this. And it will give you the code, and then you can tweak that code. So this is vibe coding, and but it's also a useful productivity hack, even if you're an experienced coder, because coding is time, and time is money for all of us at work. So being able to get a good start on this can save you time, even if you're going to come back and start editing it and modifying it and adding advanced capabilities. So I wanted you to see really early on that you can open gemini.google.com and you can give it a prompt to generate code. So there's some prompting techniques that you should be aware of for scientists, since and technical programmers and business persons and so on, because you probably value precision in the answers. If you're using it to create a new Taylor Swift-like song, maybe less so. But if you're using it for scientific and technical computing, here's one technique. In the basic zero-shot prompting, you just ask it the direct question, but you ask it with specifics instead of vague. So summarize this, and then pasting in text, that's okay. but summarize the following abstract for a non-specialist audience, focusing on the key outcome of the experiment. Limit the summary to 3 sentences. That is still a single shot, but it is much more specific about what you want the output to be, and it will give you either exactly what you want or very close to what you want in that second example of zero-shot programming. Number 2 is role-playing, setting the stage for expertise. The 2 examples here are explain how to prepare this chemical solution or giving it a role. Act as a senior laboratory safety officer. Write a step-by-step standard operating procedure for preparing 1 molar solution of HCl. You can see the rest of the prompt on this slide. The more you tell it to be an expert and the more expert guidance you give it, the more the prompt will tickle all of the parts of the trained model that relate to expertise that has been trained into the model and give you more expert output. That's a very important thing to realize about these models. It's the same model. It's coded with the world's available information, but getting the expert information out requires triggering that with prompts that are asking for expertise, telling it to act like an expert, etc. Few-shot prompting, guiding by example. So this is where you give 2 or 3 examples, and I hope that you can read the examples in the text window that I copied from a console here. But you can provide examples of the input-output pattern, and then it can replicate that. It's the most effective way to actually control the format of the output is by giving examples of the output. And this was for extracting data from text. So this can be a really powerful way of extracting something from examples. Another great technique for scientists is chain of thought programming, forcing the model to think, giving it things to do in a step-by-step way. Now, there are reasoning models that are implementations of these foundational and frontier models that force them to do things in steps, but you can encourage that. And the more you have it do things in steps, the more likely it is to get to the end correct answer. Why? Because it's filling up its context window with more and more relevant information. And instead of making a leap to the end where it might hallucinate, it's doing simple tasks and building a body of correct information in that context window that all acts to influence what the next token generated is. So forcing it to do step-by-step reasoning actually helps improve getting to the right endpoint. You've probably heard of techniques like retrieval augmented generation. We're not going to talk about how to set up RAG tools in this class today, but I wanted you to see that it's really just a way of coding in source information in an embedding and vector database, and that improves the prompt you put in. So as a user using a RAG system, you're still executing a prompt. You can see prompt version 1 here. And then your RAG system goes behind the scenes using your source data, and it improves that prompt behind the scenes, and that's what ends up in the context window being fed to the LLM and improving your output. Now, most of you are experts and have probably heard of RAG. In fact, if you've heard of RAG, do a plus sign meatmoji right now. Okay, so I can see some of you definitely have. Great. With RAG, you can improve it, but there's some work in RAG systems. The good news is we're getting better at hiding a lot of that work with tools like NotebookLM and making it easier to get precision out of data that you give it in real time as opposed to advanced training of these RAG systems. But behind the scenes, what you should know is it's still restructuring your prompt, but inserting lots of facts into it. And those facts, once in the context window, take priority and do a great job, at least, of preventing hallucinations. So in summary here of this opening theory session, generative AI creates, it doesn't just analyze. That's really important for you to know. The engine is the LLM. It's kind of like autocomplete on steroids in the way that it works. Your prompt is starting it, and then it continues generating stuff based on the prompt that you gave it. Your most important new skill is prompt engineering. It's underlined because this is a skill. You can get better and better at prompt engineering. If you continue to type 5 to 10 word prompts, you'll get okay answers. But if you're willing to invest some energy in great prompts and in addressing the format and the task and the tone and the persona, you'll get increasingly good and useful answers. And the golden rule of prompting is context is king. LLMs know nothing about your specific needs unless you tell them. So converse with them. Tell them what you want. Think of them as a really smart apprentice or junior employee or postdoc. They're very knowledgeable, but they need guidance. So some recommendations: be aware of hallucinations and how to fight them. One good way is infusing more facts into the prompt. An even better way is using source grounding, and we're going to get to that coming up. Give the AI role to play. It will play that role, and that will improve the quality of the answers you're expecting from it. If you want expert information on quantum computing, tell it it's a quantum computing expert. If you want basic information, say, I know nothing about quantum computing. Can you tell me what the basic ideas are? So you can give it guidance on the expertise level. Provide examples, few-shot prompting, and unlock reasoning with chain of thought. So some homework I want you to do, not during this because we're jumping to the next section, is do some literature reviews, try some coding, try writing, try brainstorming. Try this for every day of the week for a week. Try some different things. Build a habit in of doing this, and I guarantee you it will change the way you think of these, and it'll begin to change your workflow. So now we're going to talk about actual tools. The two that we're going to focus on today are Gemini Pro, and its interface, its web interface is called Gemini Canvas, and NotebookLM. Next time, I'll talk more about AI Studio and Gemini API. If you're using Gemini Pro through its Canvas interface, its web interface, or just through an iPhone or Android phone interface, it's a general purpose conversational AI experience that, by the way, you can talk to now in voice mode. You don't have to just type with. You can actually have conversations with. It's powered by the Gemini Pro model, has access to a vast range of information from the public internet. So it's got broad knowledge. It can do creative generation, and it can be multimodal, although most people still use it for text or voice from text. You can use it for images and video and such. How should you use it as a scientist? This is important. One way is to use it as a brilliant colleague who's read most of the internet. So this is really handy. Now you've got some brilliant bookworm colleague that's read the whole internet, and you can converse with them and have them teach and explain things to you that you haven't had time to read yet. You can use it for initial brainstorming before you have specific sources, like what are some emerging fields where bioinformatics and material science intersect? Note that prompt has bioinformatics and material science, and that's going to tickle the trained part of the neural network that can access information about both of those and find places where those two areas intersect. And then for drafting non-scientific content, like write a friendly follow-up email to a collaborator. So you can use it as the Canvas as an AI workbench for co-creation, for iterative refinement, and making sure that it's context aware. And so I would use that web interface as opposed to the mobile app interface for things like manuscript and grant writing, for coding and development, and for structured brainstorming. These are ways that it's really useful beyond those simple prompts we've all seen examples of. Try it on manuscript and grant writing. It's read tons and tons of grants that are out there. It can help you improve your grant writing. For coding and development, it's read probably billions of lines of code in lots and lots of languages, and it can help you with that. Structured brainstorming as well. So here's a quick lab. I want you to open a web browser window, go to gemini.google.com, and I want you to prompt it with this prompt. I am learning how to use Gemini. Create a web app that shows the current weather conditions for the 10 largest cities in the world. It's a very straightforward prompt. But if you've never used Gemini to create a live web app, this is going to be an aha moment for you. This isn't just producing some text as an answer, as an alternative to a Google search. This is producing a working web app with a visual display right in a browser window. It's very powerful. See if I can switch screens here real quick and show you what it did for me. It's on the right screen here. I don't see that screen in mine, but hopefully, how many people have already typed this in and generated a web app? I think that's good. All right. And how many people are having trouble with it? Thumbs down if you're having trouble. No one having trouble. Great. All right. So how many of you, is this the first time you've ever made Gemini code something for you? Thumbs up if it's the first time you've ever made it write working code for you. Oh, a lot of folks. Good. All right. So that is your hello world moment of programming right there. It doesn't just return language text. It can return code text for you and working code text. Very powerful. So what does NotebookLM do? Well, this is your specialized research tool. And I think this one's underappreciated, although people as famous as Jensen Huang, CEO of NVIDIA, says it's an indispensable tool for him. This is really important because it's source grounded and it gives you exact citations to the sources. This reduces hallucinations. The 3 bullets on this slide are incredibly important. You use Gemini to ask questions about the world's information at large. You use NotebookLM and upload specific sources that you know are important to the business plan you're writing, or to the grant that you're writing, or anything else you're preparing that you know needs to be fact-based and driven by source, ground truth data. So that grounds it. And in fact, NotebookLM is trained to focus on the sources that you give it. They could be URLs, they could be PDFs, they can be Google Docs. In fact, the NotebookLM Enterprise version can see all of the data that you have without ever sharing any of that data with anyone else. Privacy rules apply. It's your data. It's not used to train our models. It's never revealed to anyone else, but it can use everything in your Google workspace as potential information for training. So that's a really powerful thing. How should you use this? So this is a great one for literature analysis. You upload 20, 50 papers on a topic, and it can compare methodologies, identify contradictions. Incredibly powerful way for getting on top of a field fast, for which there's a number of papers you don't necessarily have time to read all of, but you want to ask specific questions that pertain to all of them. Analyzing your own data. This is where you upload your lab notebooks, experimental protocols, etc., and raw data outputs. Note it's not just papers. Lab notebooks, experimental protocols, raw data outputs. All of this is source grounding the prompts that you're going to ask with this content you're giving it. And you can create study guides. There's all these articles out there about, is AI making us dumber? AI can absolutely make you smarter by creating study guides and training you to know this source material even better. So I do want you to try this on your own afterwards, because I didn't want to go through the time of everybody uploading the same sources into their NotebookLM. But instead, I'm giving you an example to follow through here. So a graduate student is preparing for a qualifying exam on CRISPR-Cas9 gene editing. They've been giving a reading list of 25 seminal research papers and review articles. The goal is to synthesize this information, understand the key discoveries, and identify the main researchers, and that will improve their education as a graduate student. So the goal, to create a personalized expert study guide from the 25 papers. The action in NotebookLM is you create a new notebook called CRISPR Exam Prep. You upload all 25 PDFs as sources. Then you can do things like, first questions of timeline. Create a timeline of the key experimental breakthroughs in these sources, including the primary authors and the year. Provide citations. The second question, compare the methodologies used by the Doudna lab and the Zhang lab for delivering the Cas9 system into cells based on the provided papers. The third question the graduate student was assigned was generate a list of 5 potential exam questions and based on the ethical considerations discussed across all the sources. Now you're getting an idea of how powerful NotebookLM is. It's still been trained on language using the Gemini Pro Frontier model, but NotebookLM takes that model and wraps other capabilities around it to be a specialized research assistant. And this is the power of generative AI models wrapped in other tooling, other infrastructure, and why that can be so valuable, whether it's our other tools, whether it's Anthropic's, whether it's Microsoft's or OpenAI's. These foundational models are the engine, but you can wrap other code around that to give different capabilities and use that engine as part of a system for achieving even higher level functions and capabilities and purposes. So real quickly, what are the differences between Gemini and NotebookLM? One is the source of truth. Gemini uses the open internet. which includes a lot of true stuff and some not so true stuff, versus your data, your information, the sources you give it. So NotebookLM is a closed world system. It bases its answers on the information you gave it as being true, or at least as being valid source information. You can give it papers that contradict each other and ask it about contradictions, but it's going to base its answers on the information you upload. It uses the foundational model to converse in language, but it uses the uploaded sources for the purposes of extracting information, summarizing, and analyzing. Another one, broad creation versus deep analysis. Sometimes you want to create a marketing plan. That might be more in the broad creation thing, or an event plan. But sometimes you want to do deep analysis of data. So upload data, upload examples of quarterly reports, upload examples of plots and things, and that will give you a capability to do deep analysis with NotebookLM. Also, do you want general responses, or do you want inline citations so that you can cite the sources for your work? In science and technology, and increasingly in business, these inline citations can be very valuable in conveying a degree of confidence that the information is factual. I'm going to give you a quick overview of AI Studio before we move on. This is sort of the scientist's kitchen. You can try this on your own between now and 2 weeks from now, when I'm going to give you examples of AI Studio. But this is where you can do very precise prompt engineering and save your great prompts and fine tune these prompts. You can do parameter tuning, including temperature. Remember, I talked about temperature several slides ago. This is where you can adjust the temperature to get more precision or more creativity. You can experiment with structure of your output, and you can get code out of it as well. AI Studio, scientist kitchen, scientist lab, depends on how you want to think about it, but it's a really powerful place to experiment, and we'll go into some demos and labs with that next time. So the way you would use this is to automate repetitive tasks. You use it for data extraction and for building custom tools. And as I said, more of that in part 2. So in summary of these tools, before we move to some additional tools that I hope you'll start using every day and that we'll have labs on, Gemini Canvas is your AI workbench or your co-pilot. So Canvas is the default web interface, the all-purpose starting point. NotebookLM is your AI research assistant grounded in your documents or information that you tell it to use for grounding. And the AI Studio workflow is where you perfect a prompt, then grab the code afterwards. And so some recommendations. I want you to always remember source grounding is a game changer for science, right? I use Gemini Pro far more than I use NotebookLM, but there are times where you want to be source grounded. And don't forget the value of that in science and technology and business and so on. And NotebookLM gives you that. So if you want to brainstorm and write a grant proposal, use Gemini Canvas. If you want to find all mention of CRISPR-Cas9 in your 50 PDFs, use NotebookLM. If you want to build a Python script that automatically summarizes new papers from an RSS feed, you might use AI Studio for that. They do work better together. So rather than trying to use Gemini for everything or any other chatbot for everything, you might consider using tools based on these frontier models to accomplish a workflow. For example, you might use Google Scholar, which is more search-based, to find papers. Then upload them to NotebookLM to understand the key findings and identify gaps in the literature. If you're like me, you wish you had time to read all the papers and source materials, but you do not. They are being produced at a rate that no human could ever absorb all of them, even in a niche domain. But NotebookLM can help you summarize and analyze these. Then move to Gemini Canvas to brainstorm a new hypothesis based on those gaps and to generate Python code to model it. And then automate. If the analysis needs to be done repeatedly, perfect the workflow for that in AI Studio. Now I'm going to talk to you a little bit about agentic AI. And this is expertise in action. So this workflow, I hope that you will experiment with this between now and the next session. Try out NotebookLM and Google Canvas in particular, and I hope you'll play with AI Studio as well. But agentic AI can add even more capabilities to this because it adds action. So an agent is an AI system that can perceive its environment, make decisions, and take actions to achieve a goal. So what is an LLM versus an agent? Well, the LLM responds. You've seen Gemini responses. You've seen Gemini-based tools like NotebookLM response. The agent acts. It can use the tools, run the code, browse the web, etc. So it's got a plan, act, observe loop. This is why agentic AI is all the buzz now. It can create more autonomous systems. It can take more actions, even in human-in-the-loop systems. So you might be wondering, well, is NotebookLM agentic? Because I'm uploading all these sources and it's doing this analysis. No, it's not agentic. It's still an LLM-based tool with additional coding around it. It is a source-grounded reasoning engine. So think of that as you being the researcher and you're the one taking the actions and directing the workflow when you use a tool like NotebookLM. But with agentic AI, you could give a high-level agent, one of which I'm going to show you shortly, an action, and it does the work for you. So that's where you're more of the lab director. NotebookLM, you're the researcher. You're giving a lot of guidance. Agentic AI can elevate you to the role of lab director, and it goes and does things on your behalf like all of your lab staff might do. So a lot of these agentic AIs are multimodal systems. They integrate audio, video, images. They're really at the forefront of the knowledge frontier, and you can create these workflows and mix modes into these things. I'm not going to show, actually, I will show this video. We have just enough time. And again, submit your questions with an email address, and we'll get back. And Mary, let's see if we can make this work, or if I have to show this next time. No, the video is not playing, so I'll show this video next time.
I'm here with the latest research prototype of Project Astra, and we're going to see how it can help me fix my bike.
We showed this video.
Hey, go online and look for a user's manual for a Huffy mountain bike.
I have found a user manual for you. What would you like to know about it?
Okay, cool. Now scroll until you find the section about the brakes.
Sure thing. Looking for that page now.
I think I stripped this screw. Can you go on YouTube and find a video for how to fix that?
Of course. I'm opening YouTube now. This looks like a good video.
Okay, that video goes on for a while, but I wanted you to see that it was voice interaction, presenting different kinds of information. Imagine that in scientist mode or in business mode. And that's the kind of thing that we're working on now. We're moving from LLM plus prompt to LLM plus retrieval, as you saw in that video, to LLM plus retrieval and actions, adding many tools into a reasoning loop and building multi-agent systems. This is going to be incredibly powerful. We're at the very beginning of these multi-agent systems, but increasingly you'll be able to run your company or organization or lab or workflows with these multi-agent systems. And the vision is a unified platform to unlock value, be it science value or monetary value or whatever, by connecting your data sources, searching with AI on top of the sources, and a lot of AI automation. And so what we're building is, this agent space enterprise AI platform. Enterprise is important because that tells you that it's protecting your data and giving you exclusive use of your data, not using it to train models or exposing it to anybody else. It is truly an enterprise-grade platform in privacy and security, and it is allowing you to connect other tools in there as well. So not everything in this enterprise AI platform is an AI tool. It connects lots of other tools as well, but you get more powerful overall systems and workflows when you're leveraging AI agents to connect these things and perform some of the roles. And you can use agent space to build some of these. A couple of really powerful ones. Deep research is like the kinds of, it's like Gemini on super steroids. Instead of having one LLM going out and browsing the entire internet of information, it sends many, many agents out there to do deep research on a field that you give it. It can generate a much more detailed report on something and help make you an expert on something. This is an incredibly powerful capability if you're pursuing a new business opportunity, a new scientific opportunity, or whatever. And it does this it helps you solve these difficult problems, and it really is revolutionizing brainstorming and innovation, because you can define a goal, generate, review, compare, improve, and combine, and continue this in an active loop. This is really powerful, and it's using agents to go above what a single Gemini Pro instance can do. So you might be wondering, well, isn't it just like NotebookLM? No, NotebookLM is like the expert librarian in a specific room on the books that you give it or the library that you assign it to. Agent-based deep research is like a team of detective librarians that goes out and sends agents out to scour everything and come back with a comprehensive report. There's one more called Idea Generation Agent that I wanted to talk about, but the demo takes a little time and we're nearing the end. I want to make sure and talk about our final slides. So I will show you this in part 2 of it. But the idea of idea generation agent is that you can ask it to generate new ideas for your research team or your business or your organization to pursue. And it's an agentic system for scouring the ideas that have already been pursued and published and finding novel ones, for example, and finding new things that connect various source materials but haven't been pursued yet. It's a great hypothesis generation tool. So deep research and idea generation can be used together. You can gather and synthesize with deep research. Then you can innovate with idea generation. I have an example here that I'll run for you at the beginning of the next summer school. And the example is, I am interested in creating more sustainable materials for packing food products that are safe, inexpensive to make, and can be sourced in the US. Create some new ideas to explore. And I'll share the results of that with you next time. It's a really powerful capability. And what you'll see, it doesn't generate one result like Gemini Pro might do, and it might generate a different result for each one of us who tried it. It will generate 100 different ideas, and it will compete them against each other and let the best ones percolate to the top, giving them an ELO score like in a chess tournament. And this is a powerful capability that we'll talk more about next time. But as we're winding down, I'm going to save Gemini Code Assist and Gemini CLI for next time.